Welcome to the video presentation of the decision support system aiming at selection and sizing of the renewable energy configuration, matching the needs and renewable potential of your location. The simulator you are about to be presented is developed under the research project called Energy Warden, funded by the European Commission within the 7th Framework Programme. We will now present you with one interactive simulation run and guide you through all the steps necessary for obtaining the renewable energy configuration based on the multi-criteria decision-making analysis. At the welcome screen, the user is offered to enter the credentials or to obtain one after the registration process as following. New users are required to enter some general information such as name, email address, and of course the desired username and password. Mandatory fields are marked with asterisk, and CAPTCHA challenge response test is used to prevent spam registration. After providing the valid credentials, the user is transferred to a project management page where he can create a new project or manage all the projects he has previously created using the Edit, Delete or Copy Project option. When a particular project is selected from the list, a short description is presented below. For the purposes of this presentation, a project called Showcase is created and will be further elaborated after selecting the Edit Project option. This brings you to the page where you can edit the project details. At the very beginning, you should be aware of the several functionalities that will follow you throughout the simulation run. The arrows found in the upper left corner are used to move from one tab to another. Next to them, you are able to see the name of the currently active project and a short drop-down menu offering to view project details, change the active project and to save the project. Next to the drop-down menu, you are provided with a checkbox indicating whether you want to have your project automatically saved or you are going to do it manually. Of course, selecting the automatic save option will save you from taking care whether the data you have inserted are properly stored, but on the other hand, it will produce a short delay each time you move to another tab or window in order of performing the automatic save action. Following to this, an online tutorial containing both the descriptions of how to use the Energy Warden simulator as well as main theoretical backgrounds behind it are available on clicking the help icon in the upper right corner. Right next to it, you can use the logout button to close your session. The general project information is listed on the left side of the screen, where they can easily be entered, selected or chosen from the drop-down menu. Following to the text boxes depicting the name of the project and the project description, you should select the building status indicating whether the project is about new or existing building, and the building type suggesting if the case is about dwelling, office premises, industrial building, and etc. The location of the building is then required, including location latitude, longitude, and altitude, which can be inserted both manually using the text boxes or selecting the desired location on the Google map. If you choose the second option, you can use the address box found below the map, which after you click on the Find Address button, will pinpoint the location on the map. You should also notice that the text boxes containing the geographical coordinates of the location, as well as the country code, are populated based on your location on the map. Using the standard features of the Google map, you can navigate to the desired location. However, while picking a location, you should be aware that historical hourly-based meteorological data are available only for the 27 locations depicted by small blue icons on the map. The nearest location with the data will be considered otherwise. To continue to the following step, the Data Entry tab, you should use either the appropriate button from the bar or use the navigation buttons. Once you get to a data entry page, you are required to enter or review various data related to your project divided into 4 categories, found on the left side of the screen. These are building data, meteorological data, energy use, and energy pricing. At the beginning, you are automatically offered to enter the building data. The building data considers space availability for the installation of RET equipment, and the 4 main categories are foreseen. These are roof surface, surrounding area, wall facades, and the basement. Data are entered in the appropriate text boxes and will have direct influence on the sizing of the RET configuration, as they represent a space discrimination for each configuration taken into account. Moving further to the meteorological data part, you will be presented with the historical meteorological data for the location you have previously selected. Although the data used for the calculations are based on hourly resolution, at this point you are presented with average daily values for each month for better evaluation of the renewable potential of the location. Selecting a desired tab, you will be provided with the temperature, wind speed and the solar radiation data. The exact values are available by putting the mouse over a particular point in the graph. Just below the graph, you are provided with a comparison of the average value of the specific meteorological parameter for the selected location and the threshold value, which suggests that the specific renewable energy is not feasible for exploitation. Following is the energy use part, which aims at collecting the data related to your energy consumption. In order of defining your hourly energy use profile, you are offered with this advanced form for inserting the devices and their corresponding working or non-working hours. The first step is to enter the relevant holidays for your location, which will be used for creating some of the corresponding use profiles. It should be pointed out that when creating a project from scratch, here you are offered with a list of national holidays for the country that the selected location belongs. Following is the creation of the use profiles, for which you should enter name, type, which suggests exactly on which days the profile refers to, the range of dates in which the profile is used, the relevant hours for each day within the selected dates, and finally to mark whether the selected hours will be working or non-working. An additional field is foreseen for the description of the use profile, which you can use for your personal remarks. The use profiles can easily be added or deleted without restriction, regardless of their number. Once you have defined your set of use profiles, you should proceed to the definition of the list of devices. Adding the new device will require entering the name, number of units, rated power of a single unit, actual to nominal power ratio, and the time of use coefficient, suggesting the percentage of time the device is working with its full power. Finally, in order of taking the device into account during the calculations, each device should be assigned with at least one use profile or their combination, easily accessible and manageable from the pop-up window. The left side of this window contains the whole set of the use profiles previously defined, whereas on the right side you can see the ones selected for a particular device. After defining all the devices and the corresponding use profiles, you can review your results by calculating the hourly energy consumption. However, following the Go to Monthly Bills link before running the calculations will enable you to enter the energy bills, which will serve for calibration of the energy use simulation. The entry form for energy bills considers definition of name, dates range for which the bill is valid for, and of course the quantity and price. By default, you will be presented with a form containing regular monthly billing periods. However, you can easily disregard this and define your own billing periods from scratch. Furthermore, even in the case in which you have energy bills for just a part of a year, you should enter this data and the calibration procedure will be undertaken for that specific period only. Once you have entered the energy bills and selected the option to calibrate the energy use model, you should proceed to the revision of the energy use results by clicking on the icon with a graph or a table, suggesting how you want to have the results presented. Clicking on the graph icon, you are presented with a profile of hourly based energy used values, which you can easily inspect in details, changing the time span using the buttons above the graph. Clicking on the table icon, the same results are available in a table clearly indicating date, hour and energy consumption value. Furthermore, the total yearly energy consumption value is provided in the upper right corner. At any time, you can download these results in CSV format. Following is the energy pricing part, which serves for entering a pricing scheme for both energy purchase and energy selling to the power grid. The data entry form is developed in such a way to support the definition of any pricing scheme, since it provides the combination of both energy zones discrimination as well as tariff period. Adding a new energy zone requires the definition of the base price of the kilowatt hour that applies for the particular energy zone as well as the upper boundary. However, you should be aware that when a new zone is added, its upper boundary should comply with the ascending order of the ones previously defined. Moving to the right of the energy zones tables, you are provided with an option to select whether the defined base price of the kilowatt hour should be applied throughout the billing period or in the end of the billing period, having as a consequence that all kilowatt hours consumed are charged with the corresponding base price. Furthermore, an option to select the billing period interval is given in order to reset the base price accordingly. Moving further below, a list of holidays previously defined within energy use part displayed for easier definition of the tariff periods. Adding a new tariff period requires the definition of name, followed by selection of type of the day from the drop-down list, the corresponding date, and hours range. The price is entered in the subsequent columns, having in mind two options, either as an exact value or as an offset of the base price depending on the energy zone scheme. Of course, only one option can be considered in the calculations, and this is achieved as following. If the price column has a value different from 0, this will be regarded as a price for the corresponding tariff period. Otherwise, an offset value will be utilized, offering an option for both positive as well as negative discrimination of the base price. Having in mind that different tariff periods can overlap in time, which can of course create a price conflict, a level of priority for each tariff period must be assigned. This is achieved by changing the order of tariff periods using the arrows on the right to shift up or down, having in mind that the order of priority is decreasing with the order in the tariff list. Similarly to the energy use part, once you enter the tariff period, you should proceed to the revision of the energy pricing results by clicking on the icon with a graph or a table suggesting how you want to have the results presented. Clicking on the graph icon, you are presented with a profile of hourly-based energy pricing values, which you can easily inspect in details, changing the time span using the buttons above the graph. Clicking on the table icon, the same results are available in a table clearly indicating the date, hour, and energy price value. At any time, you can download the results in CSV format. After revising the results, you should get back to the energy pricing and define the pricing scheme for energy selling using the link at the very bottom of the page. You will find the same entry form for energy selling as for the energy purchase, although in most cases you will probably use just one value indicating the feed-in tariff for the renewable energy. However, this advanced interface for implementing more sophisticated energy selling pricing schemes aims at supporting the increasing development of the smart grids, which consider more diverse energy trading options. After completing all the steps within Data Entry tab, you should proceed to the Red Configuration tab for selecting the red configurations to be taken into account for further analysis. On the left-hand side, you are provided with a list of filters that will help you to discriminate the configurations that you are not interested in, or you can easily select all of them using the checkbox below. The thumbnails of the configurations are presented in the center and can be easily browsed using the navigation pane found at the bottom. Each configuration can be easily magnified on click, and the layout of the included components is clearly depicted. In case you would feel more comfortable having the Energy Warden simulator to suggest the appropriate configuration, you should follow the link in the left lower corner of the page. At this page, you are presented with a set of questions that will help EVS to realize your location's potential and to suggest the best configuration or a set of them that match your needs. Before you start answering the questions, you're reminded about the feasible renewable technologies related to the meteorological potential of your location at the top. After answering all the questions, you should proceed to view EVS recommendations, where all the configurations are listed, having in mind that the ones already selected completely match your needs, whereas the ones that are not selected match partly, and finally the ones which are shaded and should be disregarded. At any times, you can get back and select the desired configurations manually. The following step is Red Configuration Review, where you are expected to enter further information about each selected configuration, or eventually discard some of them in case the renewable energy potential is not satisfying. This will be clearly stated in a red label. Starting from the left, the typical financial data are required, ranging from the cost of capital over the state grant for acquiring the RET equipment, and finally to the project budget. The center of the page is devoted to the energy management strategy that will be applied for the simulation of the particular configuration. Using the drop-down menu at the top, you're presented with 4 different energy management strategies ranging from optimal financial benefit over peak shaving with suboptimal financial benefit, towards the limited battery cycles with suboptimal financial benefit, and finally the no grid and suboptimal financial benefit. Just below, you are provided with a list of tunable parameters which are used to fine-tune the selected energy management strategy. If you feel reluctant to change any of these parameters, you can proceed with the ones offered as default, since they are acquired from the EVS best practice. Finally, to conclude the review of a RET configuration, you are provided with a list of criteria that will be used for the multi-criteria decision-making analysis. The listed criteria present a combination of both economical as well as environmental parameters, which provide a unique evaluation of each configuration. Moreover, different criteria can be considered with different weights, giving you the possibility to arrange the relative order between them, thus steering the configuration selection process in any desired direction. Following to the RET Configuration Review tab, you should proceed to the following step of RET manufacturer selection, where you can select an exact device for each type of RET equipment. In the top left corner, you are provided with the drop-down list of all previously selected and reviewed configurations. After selecting a particular configuration from the menu, the list of RET components is dynamically adjusted and you are offered to select the corresponding devices from various manufacturers. In near future, the list of manufacturers will be directly connected to a database especially designed for hosting the information from most respectful RET device vendors. Moving further to the next tab, you have reached the final step called simulation. However, before actually starting the simulation process by clicking on the Start Simulation button, you are kindly requested to enter some device installation data which have a significant impact on the performance of the corresponding RETs. By clicking on the wind turbine, you are offered to enter the height of the wind turbine installation, as well as the height at which the anemometer is located. Similarly, installation parameters for photovoltaic panels, considering PV array azimuth and elevation, should be inserted as well. Finally, you have reached the stage at which you can proceed with the simulation run. After several moments, you will find yourself at the result page. The best ranked configuration with the corresponding sizing of devices is presenting according to the given evaluation criteria. Apart from typical economical evaluation parameters such as net present value, internal rate of return, and simple payback period, a list of configuration performance parameters from the technical perspective are also given. These are the total energy produced from photovoltaic plant, the total energy produced from the wind turbine plant, the amount of energy that was bought or sold towards the power grid, and at what cost. Furthermore, in case of configurations operating in island mode, parameters such as lack of energy and wasted renewable energy clearly indicate deficit or surplus of energy matching your needs. It should be emphasized, though, that all these parameters are calculated for 1 year period with an hourly resolution, offering a clear perspective for further optimization. These parameters are also available in the form of graph chart or available for download in CSV format. Using the drop-down menu on the top, you can easily change the graph and further analyze it using the pan and zoom features as described previously. At any times, you can check the other configurations by using the navigation pane at the very bottom, and of course compare the results. The complete list of analyzed configurations and their ranking can be seen at the higher left corner of the page. Finally, in order of creating a report for a specific project, you are requested to enter the Reporting tab and choose the project of interest from the menu. Below the menu, you are presented with a short description of the currently selected project for easier selection. Once you have selected the project, the report is generated in a PDF format by clicking on the Create Report icon. The report contains both the data entered by the user as well as some of the results. Thank you very much for your attention on behalf of Energy Warden team.